Hello everyone, welcome to OneClass. My name is Shanjida, and today I'll be going over some commonly asked math questions, both at the high school slash university and college levels. So I'm currently a second year human biology student, studying at the U of T. And lastly, if anyone needs additional schoolwork help or needs tutoring, you guys will check out the description box below. And other than that, we'll get started. So our first question here says, what if cos theta is equal to half? What is secant theta? What is cotangent theta? And so basically, to find the value of cosecant of theta, and we're given that if cos theta is equal to half, we can basically use the definition of the trigonometric identity cosine, that we know that cosine cos of theta is equal to, so the ratio is equal to adjacent over hypotenuse, right? And so comparing the given trigonometric function, so what this states is that we can basically determine that the adjacent side of the right angle triangle is equal to 1 and the hypotenuse is equal to 2, right? So since we're given that cos of theta is equal to a half, we can basically say that 1 is our adjacent side and 2 is our hypotenuse, right? And so basically, um, we can substitute the value of the adjacent side and the hypotenuse in the formula of the Pythagorean theorem, which is, as you guys probably recall, that the Pythagorean theorem states that you have a squared plus b squared equal to c squared, where c squared is your hypotenuse. And so we can basically calculate the value of the opposite side. In this case, let's say A is our adjacent, C is hypotenuse, and B is our opposite side, okay? And so to find the opposite side, we can basically just rearrange the equation. And in this case, we're solving for b squared. So to do that, we just move the a squared to the other side. So we get b squared is equal to c squared minus a squared. Okay, and so let's just substitute the values for c and a from our cos theta is equal to 1 over 2. And so we can say that c in this case is 2. We have 2 squared, a is 1, so you have 1 squared. So 2 squared is 4, minus 1 squared is just 1. And so you have 3, so you have b squared is equal to 3. However, we're just trying to find b but not b squared. And to find b, we have to square root both sides to get to cancel out the squared. So what we would do, we would just square root both sides. So your squares and your square root and your square will get cancelled. You basically have b is equal to square root of 3. Okay. And so now using the definition of sine, okay, we would have to use sine in this case to find cosecant. If you guys recall, that cosecant is the reciprocal of sine of a sine function. And so let's try to find the ratio for sine. And so sine theta, if you guys recall, is opposite over hypotenuse, right? And so we will be able to basically now determine the value of sine theta. In this case, sine theta, sine theta, our opposite sides, as we just found, is root 3. So it'll be root 3, and our hypotenuse is still the same. So our ratio of sine theta is equal to root 3 over 2. And now, as I mentioned before, that cosecant is the reciprocal of sine. So let's say since cosecant theta is the reciprocal of sine theta, we will be able to basically determine the value of cosecant theta by getting the reciprocal of the above expression, which is root 3 over 2. So thus you can say that cosecant theta is equal to 1. So the reciprocal of root 3 over 2. And so this is basically equal to 2 over root. Okay. And so therefore, we can say, so therefore, therefore, so you have therefore if the value of cosecant theta, the value of cosecant theta is 2 root 3 when cos theta is equal to a half. Okay. So this is basically our first part. And then the second part of the question says, what is cotangent of theta? Now, let's say to find cotangent of theta, if cos theta is equal to a half, we use the derived values of the adjacent and opposite sides of the right triangle in the computation above. So basically, so our right angle triangle over here, oops, oh, good. Okay, you have a right angle triangle. This is your hypotenuse. Okay, and we're, let's say cos theta. So let's say this is our angle, theta. And so let's say this is 1, this is 8. And so what we want to do is that since we know the value of the adjacent side, which is 1, and the opposite side is 2, and the hypotenuse is root. Sorry, I kind of messed up. So this is supposed to be 2 for the hypotenuse, and root 3 is the opposite, right? We can substitute these values in the trigonometric identity for tan theta or tangent theta. So for tan theta, it is opposite over adjacent, right? And so we're just gonna take tan of theta. So we're looking at theta, the angle theta here. The opposite side, as you can see, is root 3. The adjacent side is just 1. And so root 3 divided by 1 is just root 3. And so then getting the reciprocal of the above expression, we will be able to determine the value of cotangent theta. Because as you guys know, that cotangent theta is the reciprocal of tan theta. Okay. So hence, what we would have, um, what we would have. So cotangent theta would equal to 1 over tan theta. So this is 1 over, right? So therefore, a closing statement could be, therefore the value of cotangent theta if cos theta is equal to a half is 1 over root 3, right? And so we found the values for cotangent theta and cosecant theta, which is over here, right? So these two were our answers: 2 over root 3 and 1 over root. And so they have got 2 over root 3 and 1 over root. So this is correct. Our next one says simplify to root 3. Okay, so we're trying to, so since to simplify to root 3. Okay. And so this, so 2 root 3, this is a radical. And we know what radicals are. They are basically, so something that has a root. So since 3 is not a perfect square, we can't, so root 3 is not a perfect square. And so what we mean by that is that you can't really simplify the 3 under the root. So however, we can still use a calculator and get the approximate value of the number. Okay, so what we're gonna do, we can basically use, so the only way to simplify this would be to use a calculator. And so 2 times root 3 is approximately, so let's say, use calculator. And so the value of 2 root 3 is approximately equal to 3.4641. Okay? And this is approximately, since you can round this number or just put it as one whole number, but this is what the calculator gives you. So it's a decimal number, and you guys could see it's not really a whole number. Okay, and so this is the next question says, how do you evaluate 10/30 using ratios and special triangles? Okay, so what we want to do is find the ratio of 10/30 degrees. So what we need to do 30 degrees. So we're trying to find what tan of 30 degrees is equal to. So what we're gonna use, we're gonna first draw a special triangle. In this case, you guys could probably like guess that our angles would be 30 and 60 because we're using the angle 30 degrees. And so our value here, so our ratios here are, if you guys recall, would be 2, 1, 3, or you can basically say that, yeah, 1 and 8. And so to basically find the tangent function, we have to first state the ratio for tan. And so that's tan of theta. Theta is equal, if you guys recall, the ratio, which is opposite over adjacent. Okay, so where theta is the reference of an angle, and in this case, we're trying to find tan of 30. So tan 30 degrees is equal to opposite. In this case, it's 1, right? We're looking at the opposite side, which is this, and the adjacent side would be this. So opposite is 1, adjacent is √3. And so tan of 30, as you guys can see, is 1 over √3. So we can further simplify this, right? And we can basically rationalize this. So what we're going to do is, so that our square root is on the top. So let's say so we have 1, and what we're going to do, we're just going to multiply the denominator with the numerator and the denominator. I'm going to multiply bottom right. So what we get √3 over 3, right? If so, when you multiply the same roots together, the roots get canceled and it becomes the number inside the root. In this case, it's 3. So we can say that tan 30 degrees is equal to √3 over 3. Okay, and so this is your answer. So our next question says, what is 6% as a fraction in simplest form? So first, let's address what a fraction or what a percentage is. In So let's first address what a percentage is. And as it's stated here, a percentage is defined as a part of a whole, which is expressed as a fraction of 100. So what we mean is that, so let's, for example, we have a circle here and it is divided into, say, 6 parts. Okay, not equal, but 6 parts. And so in this case, so what we're gonna have is that let's let's say that, okay, out of the 6 parts, um we colored in one part, right? And to express this in a as a fraction, we would write this as, so our whole, right? Our the many pieces we have, 6. And so since one is colored, this is how you would write it in a fraction, 1/6. Okay. However, the percentage of this, you would just divide this 1/6, which is basically 0.1667. Okay. And so what we want to do is basically, so keeping this in mind, we can basically find the percentage of the fraction of 6%. And so when we're dealing with percent, if it gives you a percent, we assume that this is part of a whole. So this is part of basically a one full thing. Basically, in this case, we are saying that 6% is out of 100, so 100 resembles one whole piece, you can say. And so what we write as 6%, so another way to write 6% would be 6% is equivalent as saying 6/100. Since percentage is always, when you're talking about percentage, you're always talking about out of 100 in a fraction. And so now what it says is to simplify this fraction. So we already got our fraction of 6%. And to simplify this, we need to find a number that is both divisible by 6 and 100. And in this case, since both are even numbers, we can try 2. So we can divide the numerator by 2 and the denominator by 2. Okay, and so you get 3/50. And so you get 3/50, and we want to see if we can simplify this even more. And so 50 is not divisible by 3, so this is basically your simplest form. And so therefore the percentage 6% when written as a fraction is equivalent to 3/50. So if you evaluate 6 divided by 10, whatever decimal you get, you will get the same for 3/50. Okay, so you can say that therefore you can say that 6% is equivalent to 3/50. Is equivalent to 3. So that is, okay, so our next question says evaluate secant pi over 4. Okay, so secant pi over 4. So we can basically say that this is easy then to evaluate, because if you guys recall that pi over 4 resembles a special angle, and so in this case, we would first want to find the angle of this pi over 4, and to do that, pi over 4, to find the angle, we basically say that since pi is equal to 180 degrees, right? We can now find the angle by substituting pi is equal to 180 into this term. And so we can say secant of 180 degrees over 4. This can give us So this, if we evaluate this, this will give us 45 degrees. Okay? And so therefore, since secant is, so secant, as we call, since secant of theta is the reciprocal of cos theta, then we can basically express this in terms of cos. So you have secant of 45 degrees is equal to 1 over cos of 45. Okay, so our 45-degree angle is a special triangle, and if you guys recall, so I'll just draw out the triangle. This is so 90 degrees, and this would be 45. Will also be 45, and so the sides are the sides are basically this. Okay. So if you guys recall that cos is, so if you're dealing with cos theta, is opposite or adjacent over hypotenuse. Okay, so our ratio here would be adjacent, in this case is 1, our hypotenuse is square root of 2, right? This is 45 degrees is 1 over square root of 2. So we can now express this over here by saying 1 over 1 square root of 2. And what you get is basically you get here square root of. Okay, and so our closing statement would be secant of pi over 4, which is the same thing as 45 degrees, is equal to square root of 2. And so this is correct. Our next question here says, how to convert 30 degrees into radians? And so in converting from degrees to radians, there's a conversion factor based on 1 revolution, which is, if you guys recall, one revolution is equal to 360 degrees, which is equal to 2 pi radian. And so to convert to convert 30 degrees to radians, we have basically have so 30, so we're just going to use this conversion factor, which is 30 our degrees times 2 pi rad over 360. So we then have pi over 6. So you can basically simplify this even more. And so I'll just show you guys, I guess. And you would get 30 degrees times pi radians over, so 2 divided by 360 is 180 over 180. So then you can simplify this even more, and you get 6 here. And so you have pi, or not degrees, it's going to just be 6. And so you have pi over 6 radians. Okay. And so this is your answer. And yes, this is, so therefore 30 degrees is equivalent to pi over 6 radian. So closing statement will be 30 degrees is equal to pi over 6 radian. Next question says, what is square root of 324? So we have square root of 324. And this is, we're trying to find out what this is equal to. So let's first express 324 as a product. So we have 324. Okay, we'll express this as a product and find out the multiples of this. So let's first, so we can basically say that let's divide 324 by 2. Okay, so you have 2, 1, 6, 4, 3. Let's divide it by 324 divided by, or let's say 324 divided by divided by 12. So you have 12 and 27. Okay, and so we can further break down 12, right? So you have 6 times 2. We can further break down 27 also. You have 9 times 3. And further break down 6. So you have 3 times 2. And further break down 9, you have 3 times 3, right? And so in this case, you guys can see that our least common, or yeah, our lowest or smallest factors here are 2, 3, and 2 over here, and 3, 3, so over here, right? So our smallest factors, or these factors, are 2 and 3, and so we're going to express every 2 and 3 under a square root. So we're going to write this as square root of 324. is equal to the square root. So in this case, we have 4 3's and 2 2's. 3 times 3. This under is a square root. And so what we're going to do is group them together. So we're going to group the 2's together, and it would be 2 squared times, and we're going to group the 3's into 2's into 2 groups. So you have 3 squared times 3 squared. Okay. And so in this case, you can see that the squares would get cancelled out by the square root. And so you're just left with 2 times 3 times 3. And so if we further evaluate this, 2 times 3 is 6. 6 times 3, we have 6. 3. So 6 times 3 is 18. And so the square root of 324 is equal to 18. Square root of 324 is equal to 18. Our next question says, what is the square root of 128? So square root we're trying to find out the square root of 128. So let's first express 128 as a product. So we have 128. And so let's find a number that a multiple of 128. So 128, let's see. So let's say 128 is divided by 8. So we have 8 and we have 16 on this. So we can further break down 8 and 16. So let's break down 8. So you have 4 times 2. Further break down 4 and you have 2 times 2. We can break down 16. You have 4 times 4. Break this down, you have 2, 2, 2, and 8. And so in this case, what we're going to do is take the lowest or the small factor, which is 2 and 2. We have here 7 2's. We're going to express all of this under a square root. So square root of 128 square root of 128. Express all the 2's under a square root. So you have 2 times 2 times 2 times 2 times 2 times 2 times, right? We have 7 2's in this case. And what we're going to do is group them into 2 groups. We're going to group them into 2's. And so what we mean by that is that these 2 will go together, these 2 and these 2, and you would have 1 remaining. And so you would have 2 squared times 2 squared times 2 squared times 2, right? And so the squares would get cancelled out because of the square root, and so you're just left with, except for the last 2 because it doesn't have a square. So we would finally get 2 times 2 times 2 times the square root, right? So we can basically multiply the 3 2's out. It's going to be 2 square root of 2. So we know that 2 cubed is 8, and it's going to be multiplied into square root of 2. And so we have 128 is equal to 8 square root of 2. With the solution. Okay, so our next question says, what is 3 pi over 4 radians into degrees? So we have here, so what is 3 pi over 4 radians. And we need to find the conversion factor in order to convert this into degrees. Right? Into degrees. So the conversion factor is, so the conversion factor is basically, so you have radians times 360 degrees. So we know that one revolution is 360 degrees, or 2 pi rad, over 2 pi radian is equal to, and so your radians here, so therefore we can say that 3 pi over 4 radians times 360 degrees over 2 pi rad is equal to, so you can cancel out the radians here, the pi, and so what we have in simplify, 360 divided by 4 is 360 divided by 4 is 90 degrees, and so 3 times 90 is 270 divided by 2 is 135. Okay, so you have 3 times 90 degrees over 2, and what you have, you basically get 370 degrees over 2, and this is equal to 135 degrees. Okay. And so basically 3 pi over 4 radians is equal to 135 degrees. Okay, so this is your answer. Okay, our next question says how to multiply fractions by whole numbers. So what we need to do is basically multiplying, I'll just write the question here, multiply fractions, how to multiply by whole numbers. Right? And so basically, when you're multiplying fractions, this involves multiplying all the numerators across all going across and then the denominators going across. And for example, what we mean by this is so since let's say we're multiplying fractions, and so this is basically applicable or it goes this rule only in favor for proper um proper and improper fractions. So an example is shown, like for example we can say or so let's say for example we have we're multiplying fractions 1/3 times 3/2. Okay? This is simple. You just have to multiply the numerator times multiply the denominator going across. So 3 times 1 is 3, 3 times 2 is 6, right? And so we can further simplify this and it will be 1/2. Okay, so however, when a fraction is multiplied with the whole number, you turn the whole number into an improper function by making the whole number the numerator and then 1 as the denominator. So whenever you have, so let's say for example number 2, okay, if we have a whole number, so let's say in this case we have 3 times 3/2, right? So since 3 is a whole number, we're going to treat this, so we're going to treat this into an improper fraction. And what I mean by that is that whenever you have a whole number, there's an imaginary denominator of 1. And so basically, your 3 would become 3/1. So this is the same thing as saying 3. And so what you would have is, so the way you would express this, you would have 3/1 times 3/2. Okay? And so you just do the same thing as you did for the previous example. And you just multiply the top and multiply the bottom. So you would get 9. Okay? And so basically, our conclusion is when a fraction is multiplied by a whole number, you turn the whole number into a proper function by making the whole number the numerator. In this case, 3 would be the numerator and your denominator would be 1. And then after this, you multiply all the numerators going across and then all the denominators across. Okay, so this is for whole numbers. This for and so you can see how over here they turned this proper function by letting 1 is equal to the denominator and you just multiply across and you would get the solution here is correct. Okay, so our next question says, what is the square root of 8? Square root of 8. So let's make the square root of the number that's under the square root, which is 8, as a product. So let's treat this as product. Okay. And so we're gonna just find out the factors of 8. And so simple, we can say that it's 4 times 2, right? You can also break down 4 by letting it, so it's basically 2 times 2. And what we're going to do, since 2 is the smallest factor, we're going to take all the 2's, in this case, 3 2's, and express all of this under a square root. So you have square root of 8 is equal to the square root 2 times 2 times 2. And what we're going to do is group them into pairs. So we're going to group the first 2 into pairs. So we're going to say it's 2 squared, right? It's the same thing as 2 times 2. And you have 10. So as you guys know, that squared and the square root are inverse of each other, so they would cancel out. And so wherever there's a square, that square would get canceled out. So you basically have 2. But since this other 2, the last 2 in this case, doesn't have a square, the square root will still be with it. So you would have square root of 8. Okay, so the square root of 8 is equal to 2 square root of 2. So this is how it looks. So this is okay. So our next question says, what is the formula of the area of a half circle? Okay, so from so the area of a half circle. So I'll just draw out a half circle here. Okay, so this is how your half circle would look like. Okay, and so the formula of a normal, the area of a normal circle is, so area of a circle is, as you guys probably would recall, is pi r squared. Circle. And so in this case, since we're dealing with a semicircle or a half circle, you guys could probably imagine that the area of a semicircle, I'll just write C for semicircle, it would be half of the whole of the original formula for us for the area of a circle. So you would have pi r squared over 2, right? Since you guys could see this is half of a circle, so in obvious terms, it would be half of the original formula for a circle. Okay, so you just have to divide the whole term, the area, by 2. So yeah, this is correct. Okay, so our next question says, how do you graph x equals to -2? Okay, so x, how to graph x equals, right? Okay, so basically we're given the equation x equals to -2, and so this is in the form, so basically x equals -2. This is in the form of x equals qc. And so this has the following properties, as it is stated here, that it is a vertical line and it's parallel to the y-axis. So properties, that it is a vertical line parallel to the y-axis. Okay, and it passes through all the points in the plane with the x coordinates of C. So it basically passes. So for this, for our equation x equals to -2, it passes the point x equals -2, and so therefore the graph of the equation is x equals to -2 is a vertical line, and so with this in mind, we can basically draw out the graph. And so let's see. Graph. Okay, you would have -2 here. This is your 0, x, y, and so your line would basically go like this line. It would be one vertical line. Okay, and so it would look something like this. And so since you can see it's vertical and it passes through the point x equals to -2 and is parallel to the y-axis, and so you can see it basically. So this is how it looks like roughly. Okay, so our next question says, what is the area of a circle with diameter of 3.4 meters? And to do this, we basically have to, so the property of so the area of a circle, as we know, area of a circle we know that it is A is equal to pi, it's equal to pi r squared. So r is your radius, right? So r is the radius. And we know that the radius is basically half of the diameter. So let's say we have a circle here, right? And so the radius, so the diameter would be the whole line, and your radius would be basically, so your radius would be this or this, and your whole thing is your diameter. So you can say that r is b over 2, or r is equal or we can also say that d is equal to 2r, right? And given that our diameter is equal to 3.4 meters, we can find the radius. And so the radius would be 3.4 divided by 2, which is say 3.4 divided by 2 is r is equal to 1.78 meters. So we can basically substitute this into our equation where a is equal to pi r squared, and so a is equal to pi times 1.7 squared. So we can basically say 1 times So this is basically 2.895 meters squared. And in terms of, if you want to write this in terms of diameter, we can express diameter in terms of radius. For our area, we can say our area is equal to pi, and just substitute r is equal to d over 2 squared, right? The area is equal to pi. So d is 3.4 over 2 squared. And so you would have 2.4 squared over 4. And so if you further evaluate this, you would get around, so the area for this would be around, almost, the area for this would be 9.079. You compute this, okay? And so this is your answer. So this is what we've got. And this is, so you can put this in terms of r into radius or into diameter. Either one would work. Okay, so our next question says, what is 1.875 in fraction form? So let's first convert the given decimal into a fraction. And so the decimal in this case, so we won't want, so to convert it into a decimal, we can look at what we would do in order to get a whole number. And since this is a 4-digit number, we can basically say that to write this into a fraction, we can divide it by 1,000. So we have 1.875 and say that this is 1.875 divided by 1,000, right? Since it's 4 digits here, we can divide this by 1,000. And so to divide this, or first, what we would want to do first is times by 1,000. Okay, and so then you get 1.875. Then you would divide this by 1,000. And so we would find a number that is both divisible by the highest multiple that you can divide both the numbers into. And so it would be 125. You do that to the top and the bottom, and you would get 15 over 8. And we can't further simplify this because there's no number that is divisible by 8 and 15. So the answer is 15 over 8. Okay? So this is correct. And next question says equation of axis of symmetry. So what we want to do is find the equation of the axis of symmetry. And so at any quadratic equation in the form of, so we know that a quadratic function is in the form of f of x is equal to ax squared plus bx plus c. And so the axis of symmetry, in this case, we can say, so let's say in this case, you're saying let h equal to the axis of symmetry. And so in this case, this would be, and so the we would say basically that h is equal to negative b over 2a. So your a and b in this case are coefficients, are coefficients greater than 0. Okay? And so, as I mentioned, that h is the horizontal axis or the value of x where the axis of symmetry is located. Okay, so this is basically a formula, and for basically, so this is the horizontal axis. So this is the horizontal axis of x, or the value of x where the axis of symmetry is located. And so this is how you can find the the point of axis of symmetry by using this formula. Okay, and so this is what you've got. So the solution is correct. And so that was the end of our session. If you like this Q&A, please give it a thumbs up. Subscribe to the OneClass channel. And if anyone has personal questions or wants to ask their own or needs one-on-one tutoring services, you guys could check out the description box below and follow the links to answer your questions. Other than that, I'm Shanjida, and I hope to see you guys soon. Bye-bye.